Optimization is looking for the largest value or the smallest value a function can take. Optimization problems will usually have constraints. It is important to identify the quantity to be optimized and the constraint. Let's assign Q to be the symbol that is optimized. Using the given information, express Q as a function of a variable x. Q equals f of x. Then solve for the critical numbers on the domain. The first derivative test for absolute extreme values is important in optimization. C is a critical number of a continuous function f, defined on an interval. If f prime of x is greater than 0 for all x is less than c, and f prime of x is less than 0 for all x is greater than c, then f of c is the absolute maximum value of f. If f prime of x is less than 0 for all x is less than c, and f prime of x is greater than 0 for all f is greater than c, f of c is the absolute minimum value of f. The problem is to find the point on the line y equals 2x plus 8 that is closest to the origin. We use the distance formula in this question. Since the origin is 0, 0, we get the square root of x squared plus y squared equals f of x. We then substitute y in from the original equation and differentiate f of x using the chain rule to get that f prime of x equals 5x plus 16 over the square root of 5x squared plus 32x plus 64. We set equal to 0 to find the critical numbers on the domain. Solving for 0, we get x equals negative 3.2. We plug x back into the original equation to get that y equals 1.6. So the point negative 3.2, 1.6 is the point on the line y equals 2x plus 8 that is closest to the origin. A manufacturer needs to make a cylindrical can that will hold 3,000 centimeters cubed of liquid. Determine the dimensions of the can that will minimize the amount of material used in its construction. We need to optimize the surface area in this problem, and the surface area of a cylindrical can is 2 pi r h plus 2 pi r squared. The domain would be r is greater than 0 because a negative radius does not make sense. The constraints are the volume, which is 3000 equals pi r squared h. To solve for h, we need to solve for h in the volume equation, and we get h equals 3000 over pi r squared. We then substitute h into f of x, which is the surface area, and then we simplify to get that f of x equals 6000 over r plus 2 pi r squared. F prime of x would be negative 6000 over r squared plus 4 pi r equal, and then it equals 0 because we want to find the critical numbers. Therefore, 4 pi r equals 6,000 over r squared. Then we get 1,500 equals pi r cubed, which is, and then solving for r, we get a value that is about 7.8159. So the critical points is when f prime of x does not exist, which is when r equals 0, and when f prime of x equals 0, which is when r equals 7.8159. We use the first derivative test in this problem because we can see that r R is the absolute minimum value. Then all we need to do is solve for H using R by plugging it back into the original equation, and we get the dimensions, which are H is about 15.6319 centimeters and R is 7.8159 centimeters. So the final problem is a candy company has been selling 200 candies a week for $500 each. A survey shows that for each $20 rebate offered, the number of candies sold will increase by 200 per week. How large a rebate should the company offer the buyer in order to maximize its revenue? So to solve this problem, we first need to find the demand function, which is linear, so it would be y equals mx plus b. And so to solve for m, we need to find the slope. And y here would be the number of candies sold, and x would be the price of the candies. And we get that the slope equals -10, and we get the b value by plugging x in and solving for b. The revenue function is x times y, which is number of candies sold times the price of the candies. We substitute y from the demand function into the revenue, and we get that the revenue equals -10 x squared plus 5,200x. R prime of x would equal -20x plus 5,200. We set it equal to 0 to find the critical numbers. 20x equals 5,200. X equals 260. So, if x equals 260, the price of the candy should be $260. It was originally at $500, so the rebate would be 500 minus 260, which would be 240. So to make the most revenue, the rebate would be $240.